Below we have a herd of horses with three phenotypes. The herd has 9 black horses, 21 brown horses, and 20 white horses. The black horses have the homozygous dominant genotype big A, big A. The brown horses are heterozygous big A, little a, and the white horses are homozygous recessive little a, little a. This population of horses is in Hardy-Weinberg equilibrium because it meets the 5 requirements of Hardy-Weinberg law. We can also prove mathematically that this population is in Hardy-Weinberg equilibrium by using a chi-square test. To conduct this chi-square test, we need allele frequencies as well as genotypic frequencies. First, to find allele frequencies, you take the number of the homozygous genotype you are trying to calculate, multiply that number by 2, and add the number of heterozygous genotypes, and then divide that by the total number of genotypes times 2. The dominant allele is represented by P, while the recessive allele is represented by Q. To find genotypic frequencies of the homozygous genotypes, you have to square your allele frequencies, P or Q. To find the heterozygous genotypic frequency, you multiply P by Q and then multiply that number by 2. After the chi-square test is conducted, we get an n value of 0.6877, which is smaller than 3.84, which tells us this population follows Hardy-Weinberg law. Unfortunately for our herd of horses, a pack of wolves that hunt at night move in nearby. Because this pack of wolves can more readily see and hunt the white and brown horses, this increases the fitness of the black horses. This is an example of directional selection because the preferred genotype is homozygous dominant, and that is the direction selection moves in. To find the frequencies after selection, you take our initial frequencies and multiply each by their fitness. This gives you the unadjusted survivors. However, frequencies must always add up to 1 in order to represent the entire population. To account for this, we add our numbers together to get the sum and then take that value and divide each of our unadjusted survival rates by that value, which gives us our genotypic frequencies after selection. Now that we have our genotypic frequencies after selection, we can use those numbers to find our allele frequencies after selection. You take the homozygous genotype frequency and add half of the heterozygous frequency. This population is no longer in Hardy-Weinberg equilibrium because it violates the requirement of having no selection occur in the population, and now the fitness is not equal. After selection, we can see that the frequency for the dominant A allele increases and the genotypes with the dominant A allele increase as well. We can also see that the frequency of the recessive A allele decreases, as does the homozygous recessive genotype, because it promotes a coat color in the horses that allows predators to see them more easily. If this directional selection continues, the herd of horses will eventually be all black with the dominant big A genotype.